Okay, in this problem, or in this video, I'm going to solve 512, and then in the later one I'll do 513. They're both related to the same problem, where you have a motor with an input torque that drives a smaller pinion that then drives a larger gear that's on an output shaft. In 512, they're asking you, what's the torque that you would put on the output shaft, like a load, that would equilibrate or balance the input torque of 50 Newton meters. So again, we are imagining that this is, you could imagine it's a stalling force, but usually this is a motor that runs at constant angular speed, and then what is the output torque that you would get from the input torque scaled through the gear ratio. Okay. So let me talk a little more about gears in detail after this, but let me give you the 5-minute solution because it is an easy problem. So here I'm looking down the end. Imagine here's an input torque, then this would produce an output torque. The output torque is related to the input torque always through the gear ratio. And the problem is, you always remember, is this the inner radius over the outer radius, or is it the outer radius over the inner radius? I always forget. But, the easy way to remember is to think of it physically. At least this is the way I do it, so I kind of think of it physically. So in this situation, the driving one is smaller than the outer one. So this one, right, the angular speed of the inner one is going to be greater than the angular speed of the outer. Why? Because the line velocity is the same for both at this point. So this one, in one turn, the bigger gear has to have more line velocity. So if you turn this once, this will have to turn more than once. Okay? And since power is conserved, the input power is equal to the output power, and then the power is the torque times the angular velocity. This tells you that as angular velocity, what it's saying is that the output angular velocity drops down, so that means the torque goes up, so that they're equal, because it's the inverse relationship. So that means actually the output torque has to be greater than the input torque. Okay? All right, so that means that the way I drew this here, the gear ratio has to be greater than 1. So that means it's going to be the outer radius over the inner radius. So this should be okay. The angular speed relationship is the opposite. Okay? If this number is, if the inner radius is smaller than the outer radius, then this number is less than 1, and then what it says is the output speed drops. So this drops, and then the torque goes up. This is when R outer is greater than R inner. You could take the same logical argument for R inner greater than the output, and this will give you the opposite relationship. The speed will go up, and then the torque will go down. So it's probably always a good thing to kind of get a good feel for that. So this problem is solved just by looking at this equation. Okay? So the output torque is going to be the input torque, which is 50 Newton meters, okay, times the gear ratio. So the radius of the outer gear is 125 millimeters. The radius of the inner gear the smaller gear is 50 millimeters. The millimeters cross out, the 50 crosses out with this, and so we end up with just with 125 newton meters. So that's the output torque, okay?